Today's lesson has to do with trig identities. Statements like tangent theta is equal to sine theta over cosine theta, and cosecant theta is equal to 1 over sine theta are trig identities because they are true for all values of the variable for both sides of the equation. So we're going to be working with these type of statements. I'm going to start off with the basic trig identity. I would say these are your foundation identities. It says some trig identities follow directly from the definitions of the 6 basic trig functions. So for example, we've already gone over this. Cosecant is equal to 1 over sine theta. Secant is equal to 1 over cosine theta. Cotangent is equal to 1 over tangent theta. Sine theta is 1 over cosecant theta. Cosine theta is 1 over secant theta, and tangent is 1 over cotangent theta. Quotient identities, tangent is sine over cosine, and cotangent is cosine over sine. So for example 1, we know that tangent A is equal to 0.8. Well, we need to find cotangent A, and we know it's a reciprocal of 1 over tangent A. So cotangent A is 1 over 0.8. Since we know it's a reciprocal, it's going to be 1.25. Go ahead and do example 2. We have cotangent of theta equals 2. So we have tangent of theta equals 1 over cotangent of theta. So tangent of theta equals 1 over 2, and we're done. The next identities that I want to go over are cosine squared theta plus sine squared theta equals 1. This is a Pythagorean theorem, or it is the Pythagorean theorem, but it uses cosine and sine. And these two can be derived from cosine squared theta plus sine squared theta. So you have these other two formulas. Now remember that we're looking for cosine of A here, for example 3, and they do give you tangent of A is equal to 2/5. I'm going to show you why the second formula is the most appropriate. I'm going to go ahead and show you the steps. So you have 1 plus tangent squared theta is equal to secant squared theta. Why? Because I know that cosine and secant are reciprocal, and of course we have tangent theta. So we have 1 plus, and we know that tangent theta is 2/5, and we're going to square it, equals secant squared theta. So I have 1 plus 2 squared is 4, 5 squared is 25, equals secant squared theta. Remember that 1 can be written as 25 over 25. So I have 25 over 25 equals plus 4 over 25, which gives you 29 over 25, and that equals secant squared theta. And since we need to find secant, we're going to get the square root of both sides. So you have the square root of 29 over 5 is equal to secant theta. And I'm running out of room, so I'm going to go ahead and do it on this side. We know that cosine of A equals 1 over secant A. So we have cosine of A is going to be the reciprocal of this, which is going to be 5 over the square root of 29, which should be 5 square root of 29 over 29. So that is your answer. I know I didn't have enough room here, but I do want to let you know that at this point we have 1 plus 4 over 25 equals secant squared theta. 1 is the same thing as 25 over 25. So 25 plus 4 gives you 29. 25 is the same denominator. The square root. So here we have cosine of A, which is going to be the reciprocal of secant theta. So cosine of A is equal to 5 over square root of 29. You do the rationalize this. So you multiply both sides, the numerator and the denominator, by square root of 29. So you have 5 square root of 29 over 29. Example 4, we have cosine of A, which is 3 over 5, which is in this one. Cosine also is part of tangent, but where that's not going to be appropriate. And cosecant, it'd be secant, cosine, so that these two could be appropriate. But we want cosecant, and we know that sine and cosecant are reciprocal. So I'm going to use cosine squared theta plus sine squared theta. So here it is. It's going to be cosine, I'm going to do it up here. Cosine square A of angle A. Sine square of A equals 1. That's one that you're probably going to memorize, since that's always equal. Cosine squared A plus sine squared A equals 1. I'm going to go ahead and substitute what I have. I know that cosine of A is 3 over 5. So you have 3 over 5, and that's going to be squared, plus sine squared of A equals 1. So you're going to square that 3/5, which gives you 9 over 25 plus sine squared of A equals 1. Remember what I said about 1? 1 could be 25 over 5. So what I'm going to do is I'm going to make this 25 over 5. I'm going to subtract 9 over 25. Subtract 9 over 25. So I have sine squared of A is equal to 16 over 25. So I'm going to get the square root of both sides since it's being squared. So I know that the sine of A is equal to square root of 16 is 4 over 5. And if I'm looking for cosecant of A, I'm going to do the reciprocal, which is going to be 5 over 4. So there's my answer. I'm not going to spend too much time on cofunctions, so I'm going to go ahead and go to the next slide. These facts on top have to do with even and odd functions. And what this is saying is that if you have the sine of a negative angle, it's equivalent to negative sine of theta. If you have the cosine of a negative angle, it's going to be the same as cosine of that angle. And then tangent of that negative angle is going to give you negative tangent theta. So these are good things to remember. All we're doing here is simplifying. It's really important that you have your identities right next to you. Remember that cosecant theta, if you look at cosecant theta, it's going to be equal to 1 over sine theta. And I'm going to highlight this in blue, so you know that whatever's in blue is equivalent. So you have 1 over sine theta and cosecant theta are the same. Cotangent theta, remember that cotangent theta is 1 over cotangent theta is the same as tangent theta. So I'm going to go ahead and color that. So what we have here is 1 over sine theta. Tangent theta is the same thing as saying, and look at your trig identities, sine theta over cosine theta. You notice that the sine theta and this sine theta become 1. So you have 1 over cosine theta, which is equal to secant theta. So I've simplified it. I know that I have cosine theta, and I'm going to color it as red. Cosine x. Cosecant x, I'm going to use black. Cosecant x, if you look at your trig identities, it's the same thing as saying 1 over sine of x. And then look at tangent theta, or tangent x, or tangent theta. Tangent x is the same thing as saying sine of x over cosine of x. So now you know that sine of x divided by sine of x is 1. Cosine of x divided by cosine of x is 1. So this becomes 1. So once again, I'm looking at, to simplifying this, we have sine squared of x plus sine squared of x tangent of x squared. What I'm going to do is I'm going to factor sine squared of x. So if I factor sine squared of x, you have 1 plus 1 plus tangent squared of x. And if you look at your trig identities, the Pythagorean identities, the one that says 1 plus tangent squared theta equals secant squared theta. So we have sine squared x times secant squared x, because secant squared x equals 1 plus tangent squared x. So we have sine squared x times, that's a reciprocal, so it's going to be 1 over cosine squared x. So what you have is sine squared of x over cosine squared of x. Sine over cosine is tangent squared of x. So that's what it simplifies to. So we're going to simplify cosecant squared of x minus cosine x cotangent of x. So I have cosecant x minus cosine of x. Cotangent of x is the same thing as 1 over tangent. Oh, it's actually going to be cosine of x over sine of x. That's cotangent of x. So cotangent of x is cosine of x over sine of x. So what I have is cosecant x minus cosine squared of x over sine of x. Well, cosecant of x is the same thing as saying 1 over sine of x minus cosine squared of x over sine of x. So you have 1 minus cosine squared of x over sine of x. 1 minus cosine squared of x is actually, if you look at this identity, cosine squared theta plus sine squared theta equals 1. So sine squared theta is 1 minus cosine. So this will be 1 minus cosine squared x is the same thing as saying sine squared x over sine of x. So that gives you sine of x.